All right, let's get started. I think most of you know me. I'm Victor Pedroni. I'm the new rep for Ovivo, and the product they're going to be talking about today is the SiC. I'm going to let Elena take it from here, and I wanted to thank everybody. I really appreciate your time and effort to sit through this. Thanks. Go ahead, Elena.
Thank you, Victor. It's great having a webinar this morning with all of you guys. We put a team of some of the guys that we think that you relate to. Mike Snodgrass, he is our technology leader for SiC. Eddie, he is on the technical support. He follows up after we install the jobs. And then from the front end sales, we have Ashwini. She will focus on wet weather. Christine will focus on treasury, and Martin will focus on MBR. So the way we're going to do it is you can send me questions. I will serve as a moderator for the event. You can do it on the Q&A area, and when appropriate, I would ask the speaker. So if you come up with something that you want to know, type it in, and when is the appropriate place, I would ask the speaker. So with that, I need to turn it over to Mike first, and then I will come back with some comments.
Thank you, Elena. I hope everybody's doing well this morning, and thanks again for joining us. So wanted to start off and give some background on the SiC technology, why we have made the decision to switch to SiC, go from polymerics to ceramics, give you some background information on both the story behind it, but as well as the technology itself. Every once in a while, you see a truly game-changing technology come to our market that really changes the landscape and how things are done with regards to wastewater treatment. At Ovivo, we've been fortunate enough to work with 3 of those, and now we strongly believe we're introducing a 4th one. But just to give you a little bit of history, the original MBR patent is actually an Ovivo patent. It's something we're very proud of. And this dates back to 1969. Obviously this is sort of the foundation of where this technology came from. Certainly took a while for it to commercialize, but nonetheless, this is something that's part of Ovivo's DNA and something that we're very proud of. Obviously it took some time later, but Ovivo was the first to launch the Kubota MBR in the US market. This is really, probably the key step in launching the MBR market as a whole. In the U.S. And in the beginning, it was us with Xenon, and obviously the respective parties both felt that they had the better technology. But I think what was really important is that the 2 companies together really launched this technology into the U.S. market. So that was a very significant achievement for us. Almost 20 years later, we've now amassed over, I believe it's 400 MBR plants in the US. So pretty significant step forward, and certainly has paved the way for us in our venture into membrane-based wastewater treatment. About 8 years ago, we introduced a new technology that was focused on MBR peak flow management. Now, why this is significant is this is the first time somebody really looked at using membranes to treat raw wastewater during storm events. That was, at the time we had a bit of a narrow focus looking at how to shave off peak flows in MBR systems, and presented a very significant technical challenge that we ultimately figured out how to do. But what is significant about this, and Ashwini will certainly get into in more detail, but it sort of opened the door and paved the way to membrane-based treatment options for wet weather issues, whether MBR peak flow, CSO, all that type of stuff. So this was a pretty significant achievement for us as well. And then now what we're really focused on, and what we're here to talk about today, is the introduction of silicon carbide membranes. We really do think this is a game-changing technology. I know that's a statement that everybody has used. It's a bit overused, but this is something that we truly believe. My entire professional career has been based on has been membranes. with 16 of that being on polymerics, which are very near and dear to my heart. But I truly believe that this is a game-changing technology, and I've seen this material do something that has never been able to do before in membrane applications. Our first foray into SiC was actually in our ultra-pure water group, because they have to deal with some pretty exotic waste streams, some pretty aggressive waste streams, and that's how Ovivo first was introduced to SiC. So if we take sort of a bit of a pardon me, a bit of a step back, as we were growing the NBR business and seeing a lot of growth with the Kubota NBR, and seeing obviously a lot of growth with the GE or Xenon membrane at the time, it was kind of maybe we were a bit naive, but it was our expectation that this whole thing was just going to take over the entire wastewater treatment industry. But when you take a step back and look at the wastewater treatment industry as a whole, NBR still remains a fairly small percentage of the overall plants in the country today. Now, that's not to say we're expecting 100% of the plants to be membrane based, but we certainly would have expected a higher percentage based on the level of treatment that membranes are able to provide. So that kind of spurred the question of, well, why is that? Why is there not more widespread market adaptation of membranes in wastewater treatment, whether NBR, tertiary, sludge thickening, or wet weather treatment? And as we sort of started to dive down into that question a little bit more, we began to realize that most membrane plants operate really well. They're designed very well. They're certainly more complicated than or more sophisticated than conventional plants, but nonetheless, there's a lot of good membrane plants that operate really well. But unfortunately, there are some membrane plants that have struggled, and it's not necessarily due to the membranes themselves. And it's in those situations where the membranes sort of get a bad rap or a bad name. It's when you get some sort of process upset or some type of mechanical issue that goes wrong, and when that happens, lots of times the membranes pay the price, and it's sort of given somewhat of a negative perception of membranes. You look at this quote here, and this is direct from the EPA, and this is just talking about drinking water, which is from a treatment point of view somewhat of an easier application, and they're bringing up some concerns about membranes. So the same certainly holds true with wastewater applications. So that really sort of spurred us to start thinking, okay, well, how do we get past this sort of mental hurdle or mental block of membranes when used in wastewater applications? And when you think about membranes and wastewater, what can go wrong? And there's a whole lot of things that that could go wrong, and it's not necessarily related to the membranes or due to the membranes. You've got a whole variety of parameters that can influence performance, cause upsets, cause plugging, fouling, and also premature membrane replacement. So a lot of different aspects that can influence how a membrane plant performs over time. These are probably pictures that look familiar to a lot of us, but as you can see, no membrane technology is immune to some type of process upset. And like I've said, lots of times it has to do with something other than the membranes. The membranes are rarely the root cause of some type of plant upset, but unfortunately they bear the brunt of it. So when things go wrong, the stress is placed on the membranes themselves. So when you look at as a sort of a general correlation of membrane plants, so most plants, they operate under low stress, and by low stress, I mean that they're within their windows of operation. Everything's adhering to design guidelines, all that type of stuff. And when that's the case, they last a long time, even in NBR applications. I mean, I think some of our original NBRs are well over 10 years life and still have the same membrane. So when there's low stress and the membranes are within their intended use, they last a long time. But the problem is that sometimes they experience a high level of stress that could be due a number of issues that I've mentioned earlier. And unfortunately, when there is some sort of high level stress, it typically results in shorter membrane life. And unfortunately, that's sort of what can give membranes a bad perception, the need to have to frequently replace them. When we all know that's not necessarily the case, but unfortunately, a few bad experiences can sort of spoil a bunch. So what this drove us to is, well, why can't we have a membrane that when you do have high stress or many process upsets or frequent process upsets, why can't we have a membrane that's still going to maintain its long life? And that's really the big motivation behind SiC, which is making sure that when things do go bad, your membrane doesn't pay the price, or your operators don't pay the price and having to deal with it. So something that you're never going to avoid the upsets, but when you do, you're able to recover with it both completely and quickly. We're looking at typical issues facing membranes, particularly in wastewater. I mean, it all revolves around permeability decline, which is simply just a reflection of your hydraulic capacity. As that declines over time, you start losing hydraulic capacity. You got to clean more often. And then if you're cleaning more often, or the membranes are more stressed, then you start to experience mechanical stress and material fatigue and all that type of stuff that we want to avoid. But a lot of different factors that go into the permeability decline. The biggest and most severe is clogging, where you can get severe dewatering or accumulation of solids, debris, fibers in between the membranes, whether it's a fiber or a plate. And that can be very, very difficult to recover from. So, if these problems are inevitable, well, how can we address it? How can we find a solution to work our way through it quickly? And really, it revolves around the DNA of the membrane. And by that, I mean, what are the raw materials used to make the membrane? Because really, the properties of the raw material are going to dictate what the membrane is capable of doing. So when you look at SiC membranes or ceramic membranes in general, and you compare it to traditional polymeric membranes, it's important to take a look at what are the raw materials used to make those membranes. Traditional membranes, they're made from petroleum. They're petrochemicals, and that's been actually a huge advantage of polymerics because it's a readily widespread raw material. It can be manufactured on a large scale, cost effectively. So if it weren't for that, there probably wouldn't be as big of adaptation of membranes in general, not just in wastewater. So that's definitely been a big advantage and an important aspect of polymeric membranes. But as we sort of look to the future, we see the need to have a step change in what the material is and what the material can do. And when you think about SiC membranes, that material, it's, this is an oversimplification, but essentially derived from rocks. So you can, kind of get the perception or the idea of okay, this really is a different material. I really am going to be able to do different things with this membrane. So when you look at SiC membrane and some of the key characteristics of what both the property and the material can do, we really see three key aspects. One is the hydrophilicity of the membrane, the surface porosity or how porous the membrane is, as well as the material strength of the membrane. So when you look at the hydrophilic properties of the membrane, with SiC, it's because it is an inorganic material, it's naturally and permanently hydrophilic. So we don't have to do any modifications. We don't have to put any additives or add additional chemicals to try and impart some sort of hydrophilic properties to it. As part of the material's DNA. It's never going to go away. It's there for the entire life. So it doesn't matter how much you clean, how often you clean, how aggressively you clean, the hydrophilic properties are not going to go away. And with a true hydrophilic material, now you can completely dry and re-wet the membrane without the use of any chemicals or risk of any flux loss due to pore collapse. So that's a huge aspect when it comes to the maintenance aspect of membrane systems. So because that's part of the SiC material, you can dry and re-wet it indefinitely, and you'll never lose that capability over time. And then also, this is certainly particularly important for wastewater, is the hydrophilicity also improves resistance to organic and fog material. You know, a lot of organic components or compounds in wastewater are hydrophobic. So if you have a membrane that's truly hydrophilic, it's going to have a natural tendency to repel those hydrophobic compounds away. So you definitely do see lower organic value. I'm always a big believer in that picture's worth a 1,000 words. So keep in mind when you see this video, this is actually shot in slow motion because in real life it happens so quickly, but just to demonstrate the hydrophilicity of SiC. As you can see, the water, it's naturally attracted to the water. It actually just pulls the water in. And this is just a simple drop of water, and within a second, it immediately disappears into the pore structure of the membrane. So it's extremely hydrophilic. And just to sort of visualize the difference between a hydrophilic membrane and a hydrophobic membrane, as you can see, with SiC, the water just soaks right through, whereas, your traditional polymeric membranes, which are derived from oil, they're more naturally hydrophobic, and you've got to sort of manipulate that chemistry to impart some level of hydrophilicity. As I mentioned a little bit earlier, the hydrophilicity also helps with fouling. This is a study done by a university in Germany looking at surface water, comparing all different types of membrane chemistries, both ceramic and polymeric. And they looked closely at both reversible and irreversible fouling. As you can see with SiC, it had the lowest amount of reversible and irreversible fouling. So that's simply due to the hydrophilic properties of the material itself and its ability to repel a lot of organic material, as opposed to absorbing it into the pore structures and making it difficult to clean. Moving on to surface porosity. And when I talk about surface porosity, I'm really talking about what percentage of the surface are pores. Sort of a good analogy to think about is a strainer. And if you're draining a pot of pasta, if you have a strainer that's got thousands and thousands of holes, like in a wire mesh, the water just flows right through in an instant. But if you have some sort of strainer that just has a couple of holes, it takes a little bit longer for the water to pass through. And that's simply because you're just providing more passageways for the water to pass through. And when you do that, you can achieve much higher flux rates. So SiC is probably the most porous membrane out there, with about 50% surface porosity. And because of that, we can achieve about achieve about 3 to 5 times the flux rate at the same TMP compared to other membranes. Also, what the higher surface porosity does is it reduces your fouling. So when you think about it on an individual pore level and think about solids trying to bombard that pore as water's passing through, if you have a lot more pores, then there's certainly going to be a lot fewer solids hitting the pore surface. So definitely lowers your fouling rate significantly. And also, it's easier to clean. It's a very open pore structure, allows the chemical to easily pass through. Obviously, it has a different pore structure. There's a lot of interconnected pores, so it makes it easier for your cleaning chemical to find the plugged areas and attack whatever it is that's plugging the membranes. These are some of our flex capabilities that we've observed in SiC on the different applications. On certain NBR applications, obviously it depends on how it's designed in terms of mixed liquor and temperature, but we've seen flux rates as high as 50 GFD on NBR. Tertiary up to 150 GFD. On wet weather systems, we're usually around 100 GFD. Then on sludge thickening, where you're usually over 3% solids, well over 20 GFD. So definitely significantly higher flux rates compared to what is traditionally seen. And last but not least, talking about material strength. Now, SiC is a very hard material. It's second in hardness to diamonds. So you can imagine it's going to be very difficult to scratch it. And what that allows us to do is to implement new cleaning measures. Eddie's certainly going to get in more details on the cleaning aspect, but now we can use pressure washer to remove dewatering. Why that's significant is makes it a heck of a lot easier to clean dewatering, but do it much more quickly, and you don't have to scoop it out with your hands, so to speak. So that makes the recovery aspect significantly more effective and easier. Also, during normal operation, you're going to eliminate a lot of scratches and cuts from debris. Why that's important is over the life of your membrane, your effluent quality is not going to be compromised, because you're not going to get pass through of solids or coliform material, and that's because the integrity of the membrane is always maintained, because you're eliminating all these scratches and cuts that are very common in MBR applications. And it's also it's a chemically inert material, so we can now clean much more aggressively in terms of both types of chemicals, but as well as chemical concentration. And what that allows us to do is, once again, if you have an upset, you can hit it hard and hit it quickly to not only ensure you get full recovery, but to do it quickly. So once again, it just opens up a whole new set of options for plants and plant operators. And there's just a short little video. It's kind of a satisfying thing to actually do, is to just wash all this dewatering off, especially if you've had to deal with it firsthand, where you've got to remove the membranes and be very careful in scooping out the sludge yourself. So definitely a nice feature for our plant operators. And with that, I'm going to hand it over to Elena.
So Mike, you have actually a couple of questions. So maybe the first one is one of our customers has a facility, has a wastewater with very high amount of silica due to potable water. Would that cause any issue with the membranes? He fears that the etching characteristics, evidence of the potable water would cause irreversible damage. What do you think?
No, it shouldn't be a problem. I mean, silica fouling, that's often a water chemistry function, and by that I mean, you could be above the saturation limits, or there could be pH issues. And fouling isn't necessarily dependent on the membrane. It's more of a solubility issue. But in the case of SiC, if you did have silica fouling, it'd be much easier to clean, because silica's got a funky solubility curve where it's at its lowest at neutral pHs, but increases whether you go high or low pH. So with SiC, if you did have silica fouling, you'd have much more effective cleaning, because you could hit it with either extreme pH to clean up.
Okay, that's great. You have a couple more, but I think I'm going to wait. Another presenter will address those other two questions, and if they don't, then I'll come back to you, Mike.
Okay, sounds good.
Okay, so with that in mind, we just kind of wanted to figure out, how do we take advantage of this limitless possibilities of SiC as a company? How do we address that? So silicon carbide to us opened the door for something very unique. A lot of new solutions to existing problems that we never had as Ovivo, as a company. So what you see on this diagram is actually, you probably know us from MBR, and you probably know us from the membrane thickening, aerobic digestion. We've done more than anybody else in the world combined. MBRs, we have over 350 of them, but we have never touched tertiary, and we never touched wet weather. And so what you would see today is that when Eddie presents the advantages of SiC, this opens up a new arena for us to do tertiary and to do wet weather in addition to MBR. So we're actually going to start with the wet weather because that is so important to you locally, especially in Washington. And then we'll go to tertiary and then we'll finish with MBR. How do you change it? I mean, if you've known us for 19 years, you know that we were a licensor to Kubota and to Microdyne later, flat plate and flat sheet. But that relationship could not stay. If we really wanted to be more cost competitive, be able to actually do a lot of things with the product, improve it, mold it to what we need for tertiary, wet weather, or any other applications, even weather in the future, we needed to have a different relationship. So we now have a true partnership with Sembrain. We're investing both in their factory in Denmark and also the one that we're building here in Texas. In addition to that, we created a very strong team. The team that we created is actually a team of people who would lead us into different areas. So what you're seeing here is we have a global manager, which is Jason, and he coordinates along with all the other guys, which basically is the ultra pure team as well as our energy group globally. And we have Mike Snodgrass that you already met. He is our municipal SiC membrane technologies, but we have a factory manager, Stefan. We hired an expert on material science for SiC. He came out of Cornick, Robert. Then we have an entire design team dedicated to that. Christopher Lewis with engineering, Trevor with the design, Eddie, who will be next with the technical support, Clay on innovation R&D, as well as Dustin on mechanical design. And then we also have in our team the product managers like the MBR, and you would hear from Ashwini on the solid separation and Brian Won biosolids. And finally, we even have on the business level help from support all the way from the board. So we have a board member, Rafael, our VP, Hiran, myself, and then we also created an SiC rep council to advise us. So this is a very significant push from the company. And the goal of this team is 3 principles: integrity, maintainability, and safety. If you think about those 3 things, if you can accomplish them in every part of the design that we do, then at the end, we will have a 100% reliable solution for our customers. This is truly a game changer that we have not seen with anything else, that we believe we can provide the safest environment for our team, as well as the operators and the installers, and we achieve perfect maintainability where you basically can make the product last in a very efficient design. Those are truly the goals of this team. And with that in mind, with this short introduction, I would like to turn it over to Eddie. Eddie will basically tell you how hands-on this has changed the life of our team, as well as the life of our customers. Go ahead.
Thank you, Ellen. Don't let the title fool you. I'm a technician at heart, and I've been spending 13 years in the field, probably at some of y'all's facilities, looking at how to improve our support efforts and make life easier for everybody. Let's just talk about first basics of MBR, and it applies to all membranes, no matter what type or size or shape you have. You are going to deal with routine maintenance cleans, meaning that you're going to stop permeating for a while to perform a CIP with chemical. That happens on all products, but at some point in time, you're going to find out that that's not enough. You may have to get into mechanical cleans, drains and inspects to figure out why that clean isn't working. But the chemical clean portion itself is going to be based on basic, organic, and inorganic. And if we're focused on organic, we're obviously going with an alkaline product with a high pH. The higher the pH you can get away with without damaging your equipment, the better results you're going to get. And then obviously the lower you can get on pH for acid, the better removal of inorganic fouling you're going to get. And that's the goal, is to hit it once and get it done. But honestly, and sometimes the mechanical clean is not going to get you where you need to be. And if that's the case, you're going to drain, take a look, and investigate what the problem is. If it is just a simple a misunderstanding of what possibly chemical is needed. It's a pretty quick fix, but typically at that time, it gets down to a mechanical clean, meaning you're fully dewatered. The tank's going to have to come drain. Things are going to come out, and it's a challenge. It's a life challenge if you're an operator or a maintenance or technician for sure. So one of the things, two things that are very important is understanding your operational window, and the other thing, the tools that you can use. So over the last 12 years, when dealing with polymerics, flat sheets, and flat plate, we have done many cleans, many CIPs, both organic and inorganic. And even though you look at a range of 2 pH of 2 to a 10, or maybe they're going to tell you a pH of 2 to 11, the reality is the stuff in the middle has no relevance. It has no importance to how you do the clean. To be successful, for instance, on an organic clean, you have to be greater than 10 and preferably at least a 10.5 on your pH. But when you look at the flat sheets, you are not allowed to go over 11. That means 11, not 11.9. You have to stop at a pH of 11. So your range of operation is 10.5 to 11. Flat plate is a little better when you're doing the organic removal because you can get up to 10.5 to 11. Very helpful. I'm sorry, 10.5 to 12. That does get you more range to work with. But if you look back on the acid side of that slide, it's pretty typical. Believe it or not, so far to our knowledge and our experiences, it doesn't really matter what situation you're in or what membranes you are. Your goal is to hit a pH of 2 when doing an acid clean. The problem with that is if you get too close to 2, it jumps really quick lower to the 1, and that's outside of the warranty on flat sheet and flat plate. The benefit you're going to get with the ceramics, with the SiC product, your window of opportunity or window range of operations is going to be 10.5 to 13. That's a huge difference because now you're hitting it with a strong bleach, and if need to, you can bump to an oxalic, which till recently we have not been able to do with flat sheet and flat plate. You will cause such a problem throughout that entire CIP process that it could lead to complete membrane replacement. On the other side, on the acid side, we still want to try to hit 2. That seems to be the most effective approach. But if we mess up, and there is human error, and you get less than 2, you're going to be okay. You're not going to hurt anything. You may waste a little chemical, maybe a little stronger than you thought, but you're not going to damage the equipment, which is very important. So we talked a little bit about what standard operations is. Every plant has routine maintenance clean when you're stopping the filtration and the relax process and you're moving into the routine CIP. Again, CIP, possibly backwash if your system can handle it. But again, recovery clean. One thing that everybody wants to avoid is membrane replacement. And that is when it's well beyond fixable. But right before that, we have the mechanical cleaning. And that, again, that is the life-challenging event that I'd like to share with you over our 13 years of experience in the different membranes we dealt with. So what you're looking at here is a demonstration of flat plate and what it takes when you do dewater those membranes and they're full of sludge. Believe it or not, to the right, the fella in the white suit is me. That was back in 2007. That was my first year joining the path of MBRs. And I've been told I'm a pretty big boy, but it took more than me in that case to start that process of trying to pull those plates out. They get so dewatered and so plugged that if you're lucky, you can pull them out. If not, you're probably going to have some type of equipment, cranes, etc. But what you also see very closely on the left, you have people sitting down, holding hoses, washing down the membranes. You have to wash them from both sides. And you typically have to dismantle them to get to them. And unfortunately, once you start doing that, you have the tendency of have some human error and some damage. So we would typically see around a 5 and maybe up to 10% of damage just to tearing things apart and putting them back together. One thing to note is the amount of water it takes at least 45 GPM to be effective because about 12 to 15 gallons per hose, 2 to 3 people, sometimes more. Pulling people together and attacking this is not anything that happens quickly. The one to the right took us a week, only 9 units. The one to the left took us 2 weeks, but it was a much larger plant. And if we look at the flat sheet, there's some improvements on the flat sheet, but again, there is a lot of equipment needed, a lot of resources needed. You see down there on the right side, you see Bill at Ocean Reef handling a 3-inch hose upstream. There's a 3-inch trash pump. So it takes 2 people to manage that. And as you can see, it's very unsafe. One of the things that we want to be very cautious about today and moving forward is we don't want to put operators' life at risk. And even with the safety equipment and the PPE, you look at the middle, it's not something you can simply wash from the top. You literally have to dismantle the frame of that module to access the top and the sides and put it all back together. So you're looking at a lot of resources, a lot of time. And one of the toughest things to deal with that we found over time is it takes 130 gallons per minute per module. Doesn't matter if you have a 10,000 gallons per day plant or if you have a million gallons per plant. It still takes 130 gallons per module to clean it in up to 20 minutes. So if you have your system down and you have to fix the dewatering issue and remove the dewatering, not only are you not permeating water, you're putting a lot more water back into that system. So it is very, very challenging. So what do you get with the SiC? You are allowed to hit it with something we've never been able to hit it before. You can literally, without having to go get a crane, without having to go get a 3-inch pump, you can go to your Home Depot, get you a pressure washer, and you can literally spray the top of that unit without separating that module, without pulling out those plates. And for about 2 gallons a minute, in about 2 minutes, you should knock out a module pretty quick. And the pictures you see on the right, I wanted to give you an example of the life of an operator and what can be different from them. Do you want them to feel like when they're at work, they're basically just washing down their car? Or do you want them to feel like they're working in a toilet just to keep up with the effort and the challenges so they can get their plant back up and running? And with today, with COVID, you know, we are able to notice or identify COVID in the wastewater stream. So that means COVID can identify our operators. So we want to keep them as far away from that possibility as we can, because safety should be number one.
Sludge dewatering does not occur often in a membrane thickening system. However, it presents operational and process challenges. The maintenance required to clean dewatered sludge off polymeric membranes can be very time-consuming and extremely labor-intensive.
One of the things that I'm always asked during training is, when we have a dewatering event, can we use a pressure washer on membranes, you know, or a 1.5 to 2 inch fire hose? You know, with the polymerics, you cannot use either one of them because you will damage the membranes. With the 200 plate cassette of the polymeric, it took us about 2 days to fully disassemble, clean, and then reassemble.
In contrast to polymeric membranes, the superior durability of the silicon carbide membranes allows a pressure washer to clean dewatered sludge off the plates without any physical damage.
With the ceramic, you just need a little bit of space underneath them to allow the sludge to disperse, but you can hit it with that hose, no problem. You know, you're not gonna break them. These are durable plates, so you can just really get after it with the pressure washer. 30 minutes, you can have this whole tower completely clean. Give it another 30 minutes to assemble it, and then you're ready to put it back in service.
And just so you know, that tower he was talking about was called the M15. It has 15 modules. It was 2 minutes per module. So once you've unfortunately had to go down that road for mechanical cleaning, and I think most operators out there with MBRs can tell you they've done it once, and they'll tell you they've never wanted to do it again. You're not done there, because during that process of doing all that work, things are going to get dry. And there is something you have to be quite aware of, is you have to make sure those membranes are re-wetted or they will not perform. If you look to the right on the flat plate technology, it does have somewhat of a benefit that it can go dry and you can re-wet it successfully and get back the quality. But unfortunately, you're looking for that proprietary Quip Wet, which is difficult to get, takes time to get. And once you get it, and you perform the work, it becomes very messy, very slippery. And keep in mind, you're also pulling these things out of a tank, putting them in a tank, and it can get very dangerous. And what you need to do is be very careful and cautious to what's going on. Another thing that comes with that flat plate is foaming. When you're using that quick wet or you're using a high volume of dish soap, when you put everything back together, you spend another half a day or longer trying to figure out how to keep the foam in the tank. On the left side, we have the flat sheet. Unfortunately for the flat sheet, you cannot ever let that go dry if you've ever gotten it wet, because what happens with that one, if you do not keep it wet for the remainder of its life, it will lose probably 20 to 30% of its capacity that you'll never get back. And I don't know if anybody on the phone has ever dealt with 20% glycerin. It's basically sugar water. And again, super slick, super unsafe. And it's just time consuming, and it takes a lot of effort, typically 20 minutes per application per unit. One good thing about the SiC, one of the many good things about the SiC is the re-wetting chemical no longer needed. Once you're done with pressure washing that unit and cleaning it all up and sticking it back in the tank, it's naturally going to absorb that water and re-wet itself. So that is something that if you've ever experienced this, will definitely put a smile on your face. So I want to talk a little bit about what are the tools, what are the metrics that you use and within their operating window? What's different then versus now? TMP is standard across all MBR installations. Transmembrane pressure is, in basic terms, it's the energy it takes for me to pull that water out of the mixed liquor, through the membranes, through the piping, out the pump, and wherever it needs to go. And that TMP is going to determine when and how often do you do a cleans. It's also going to determine whether or not your plant's going to operate, because if you hit the max TMP and you don't catch it, it's going to shut your plant down. And one thing that doesn't get talked about much is when you look at the actual TMP range in your O&M manual, for instance, on the flat plates, it says 0 to 3. That's true. At 3, it will shut down. However, your real usability is only about 80%. And that applies pretty much to all your rotating equipment, your gauges, your actuated valves. If you're going to work within the efficiency of your product or your equipment, you're only going to run at 80% of its full span, if you will. So again, even though it's maxed out to 3 on the flat, you're going to operate pretty much between 0 to 2.5. Flat sheet's a little better. You can get up to a max of 5.7, but unfortunately your operating window is still limited to a 4.8, which is 80% of that max. So what benefit do you get with the ceramics and the SiC? When you're already into the max allowable TMP and driven into the red line, which is a forced shutdown required by the manufacturer, you're still riding along in your usability range, and you have plenty more room to work with. You're able to go from 0 to 10. I would like you to stay between 0 to 8, because that is 80% of the full range, and that is the efficiency zone. But again, you are 2 to 3 times greater than what the polymerics can do. Max pressure. What is max pressure? Well, when you're doing processing water and then you hit that routine maintenance clean, you're actually sending water back into the membranes with chemical. And if you're lucky enough to have the ability, you're sending backwash back into the membranes with no chemical. Flat plate, maximum 3 PSI. Maximum pressure on flat sheet, 3.7 PSI. On SiC, you can get up to 30 PSI. Now, obviously, there's a max on everything. You don't want to exceed 30 on the SiC. You don't want to exceed the flat sheet, 3.7. And you definitely do not want to exceed the maximum 3.0 on flat plate. This is what happens when you do. If you shoot over that max allowable pressure when you're doing that CIP, or pseudo backwash, they call it, you're going to tear one of those sheets on the left. You can see it almost looks like a sophapia. It literally separates that outer layer from the inner instruction. The glue does not hold, and it will breach. And on the right side on the flat plate, even though it is adhered to a stronger substrate, it's only supported around the parameters of the filter itself, of the material. So what you're doing is you're going to separate that weld from that hard material, and it's going to make a breach. And if you ever get to a point on polymerics that you get that breach and you don't catch it, it will migrate. The solids will migrate up and into the permeate header, and then between that breach and your pump, all the other membranes, all the other sheets and the modules associated with that will fill up with sludge. And again, that's not something you ever want to experience. So one thing I'd like to run into is and discuss is my team. I'm very proud of my team. I got over a group of members that together with wastewater and MBR experience, we've already hit over 128 years combined. And I am super excited about that. One thing we learned, I'm proud to say that we learned early on, probably 8 years ago, my team couldn't just be mechanics, electricians. It needed to be someone that could relate to operations peer to peer. If you look there, we have obviously Clay. He is our R&D specialist. He is currently operating 5 SiC pilots so that we can stay on top of all the new things and stay and make sure that we're on top of all the operations and the things that we do. Todd Baldwin, he has water and wastewater experience over 22 years. He has a class 2 wastewater, class 1. Just before I go any further, just so if anybody knows, when you join the world of operations and you start doing your training and your certification, they're starting at a class 4. That's the beginning. And then as the years go by, and then as you train and pass, and you become more versed on your overall life goal of being an operator, you go down from 3 to 2 and to a 1, and the 1 is as high as you can go. So that means that when you're looking at those classes, you're looking at somebody that has spent many, many years through every span of the possibilities of being an operator. And that to me is important, that we can provide that kind of service to our operators. So what do we actually do before we go out to a startup? The project manager hands us a book, and that book has the IOM, it has the specs, it has the proposal, hundreds of pages, hundreds. And back in the old days, we used to sit down and set it on the table for training and verbatim read word for word and get it all signed off. And, when you have operators with you and your team, and we're training operators and everybody's looking at them and say, this is ridiculous, we agreed. So we stepped it up and realized we need to do our part to condense the things to what's important. And that's what the quick sheet's doing. It's actually giving you all the information, all the necessary information to stay within that operational window. So the other thing that we've done over the last few years is, instead of just when a call comes in to the hotline and you get one of the area managers, one of the operators on the phone, instead of them saying, do me a favor, go download all your software, go start collecting all your data and call me back when you have it all. We've developed the system, Water Expert, and the innards of CRM, so that we can take all of that information that's already in your HMI, and it gets constantly pushed to the cloud, and the Water Expert pulls that in, and it's automatically sorting that data for us. It's already building the trends for us. So when you call that hotline, we don't have to straightforward ask you to stop what you're doing and spend a week collecting the data. We say, okay, let me log into your plant. Let's look. What was the time of day? When did it happen? Okay, let me pull up that event. Let me look and see in the data what exactly happened. And when we do that, this is just a graphic of showing what's happening inside that HMI. It has a full range of the operations. Sorry about that. The light kicked off. I'm here at the hotel. So we're actually looking at the range. The system is looking at that operational range, that usable range that we discussed in the previous slide. And if anything pops up in or outside of, or to the edge of that range, it's going to light up inside that system, and it's going to give us an immediate notification. So this allows us to be proactive to support you guys instead of the old school reactive. And I'm proud to say, when you got a group like I have, and we have that remote monitoring capabilities, we also have another team of a global support that we ensure that when we're sleeping, our big brothers and our big sisters are already looking into this and keeping look on the system and preparing us for the next day. And the whole purpose of this, yes, it's to make your life easier, but it also makes our life easier. So everybody's benefiting from it, and it's a great thing. Any questions for me, Ellen?
Yeah, Eddie, I think you did a great job from an owner's point of view. One of the questions that came in, what if you did have a bridge with SiC? How do you do that?
I didn't have that much time to put that together, but if you go back to the polymerics, it takes a long time if you're lucky. But when it comes to SiC, that 30 PSI is literally what you're allowed to get away with. And I was with the fire department for 7 years, and one thing I missed, I'm pretty excited I get to do now, I can literally go to the fire hydrant and I can take a 1.5 inch hose and I can hook it to one side of that header, and I can turn that hydrant on up to 30 PSI and literally flush that entire system out in seconds without causing any damage. So yeah, it's pretty cool.
Okay, thank you for that. There are a couple of more questions, but I think we're gonna wait until we go to the other speakers because they may be addressing them. But guys, if you have any questions, just please type them in the Q&A, and when appropriately, I would turn it over and I would ask the right speaker. Okay. So with that, Ashwini, you're up next. You're gonna focus on wet weather, which is something very close to a lot of the people that are attending today. Go ahead.
That's right. Good morning, everyone. Thanks for your time today. I'm going to talk about wet weather systems. Mike and Eddie talked a lot about hydrophilicity, wetting, and re-wetting of membranes required for polymeric membranes. So really the hydrophilic nature of SiC allowed us to think about this application, opened the window for us to enter the wet weather system application. SiC, it allows SiC to be left dry after an event, and without losing its permeability or needing any kind of pre-treatment. So let's step back and see what happens. Look at the infrastructure. What happens if it rains harder and longer than the infrastructure can handle? The flows exceeding the wastewater treatment plant capacities are going to be dumped untreated into the waterways. High level of pathogens are going to overflow, restricting human activities, the recreational activities near the water. It would harm the environment. Toxins would stay for a long time into the water, and it can make headlines. So different cities have addressed these problems differently. Some cities are set up to have a combined sewer overflow where the storm water combines with sewage water, and any flow excess of the capacities of the wastewater treatment plant would be discharged into the waterways without any treatment. And similarly, some cities have separate storm water and separate sewage water piping, but during rains, inflow and infiltration can send more flows to a wastewater treatment plant than it can handle, and which in the end has to be discharged into the waterways without treatment. So the scope of this is pretty large. EPA estimates that the total CSO discharge is 850 billion gallons annually, and the total SSO discharge is 10 billion gallons annually. So different approaches can be done for controlling the CSO SSO issue. There could be one single approach, or cities have taken a combination of multiple approaches. So basically it can be stored. You can store it in a large EQ tank, deep water tunnels, and deal with it later after the storm, or reduce it by using green infrastructure, but that doesn't really eliminate the issue. Or repair or replace what's broken, but that's not a holistic solution. And then the next solution is to treat the CSO or SSO. This is the solution we're going to focus on. There's no one solution for all these problems. Cities have taken approach of a combination of many of these. our rapid storm treatment system is focused on the treatment of CSO and SSO. With that, let's look at some challenges in CSO and SSO treatment. The thing with the storms is they come with variability of flow, variability of load, bacterial composition. That really makes it very difficult to decide and adjust the treatment based on the variability of flow, loads, and composition. So if the chlorination and dechlorination is the technology used at a certain facility to address CSO, SSO, it is difficult to predict the amount of chlorine to use, and difficult, all these chemicals need a large storage. And if the storms tend to extend beyond a certain period of time, we might run out of chemicals. There needs to be a plan to address back-to-back storms to make sure the treatment system is ready for the next storm. Instant permit compliance is absolutely needed, otherwise it restricts human activities on the waterways. In some cases, small footprints are necessary if the outfalls are in the middle of a downtown or by a residential area in the waterways. It could be in a nice residential area where CSO, SSO could look like an eyesore. Many of these facilities are unassisted satellite facilities, and an automated operation would really be nice. So that brings us to the solution that we have here to offer. This is a rapid storm treatment system. It's a physical chemical treatment system using membranes for filtration. This can easily switch between going online and offline mode because wet weather systems are required seasonally. Membranes are by far known as a means of getting really high quality effluent, and you can get it instantly. The membranes present a physical barrier for any solids to pass through, so that assures the quality of the effluent would always and consistently be good. Mike talked about the high flux that we run at. So based on our testing, the fluxes used for wet weather system are really high. 100 GFD is a high flux, and that leads to a very tight footprint. And then there are no large storage requirements here for this system. So how does it work? So during a storm event, CSO, SSO, raw, untreated waste would get into the screening, and the CSO screen would screen the influent, and then it would go to the rapid mix tanks for mixing with the coagulant that would enter the membrane basins, and the permeate pumps shown here would kind of suck the clean water out of the membranes, and the high quality effluent can be discharged into the waterways. TSS and turbidity will be monitored. Then after the storm event, the membranes would be spray cleaned. Tank cleaning would be done using a controlled water flusher, which is an automatic, but not needing any kind of instrumentation. It's an automatic cleaning mechanism that would work after the storm and remove all the solids from the bottom of the tank. It does not require any plant water. It uses the storm water to basically flush the floor of the tank. And after, and then all those solids will be sent to a wastewater plant, treatment plant, or a sewer, and the membranes would be cleaned in place after the operation. And the unit is now ready for the next storm. So one of the challenges that wastewater treatment plants see during wet weather season is that the F2M ratio is really low. The influent is dilute, BOD-TSS is low, and it presents challenges for biological treatment of a plant. with the low food to mass ratio. So this standalone unit, rapid storm treatment unit, can not only process hydraulically all the excess CSO, SSO water and discharge clean water into the waterways, but it can also send those rejected solids back to the wastewater treatment plant to make up for the food to mass ratio that it's lacking. So there's a potential of a symbiotic relationship here and not overwhelming the wastewater treatment plant with excess flow, and at the same time assuring that its performance is met. These units can be centralized or decentralized. They can be at an outfall, or they could be located at a wastewater treatment plant just to handle a standalone unit, just to handle the peaks excess of what the plant is designed to handle. They can come on and off as needed during the wet weather season. And this actually presents some kind of a source control of sorts, so that it doesn't overwhelm the sewer system with overflows coming from, high peaks coming from everywhere. So the system is hidden in plain sight, small footprint. It could be above grade, it could be below grade, and it can also be retrofit in existing tanks. This scene here is hard to spot where that system would belong. So very well hidden in plain sight and very aesthetic looking. So before we embarked on testing for pilots at different places, we decided to do some tests here in Austin on raw water. And we ran tests to see how quickly the system can come online after being dry for some time. What's the treatment level we can achieve from it? What we found is we got really good results, log remol of 6.4. We used raw wastewater, so the fecal were in the range of 7 to 10 million. From there, we got to an average of 1. BOD TSS, the same, greater than 85% BOD reduction. And TSS for membranes is basically anything that doesn't pass through the membrane. So that can be assured to be less than 5 milligrams per liter. And turbidity was less than 0.2. So definitely the system can meet at least the secondary effluent standards. The effluent can be consistent quality, whether it's the first flush or it is the following storms. The quality of effluent is going to be consistent because the membrane presents a physical barrier for anything to pass through. So we are currently, this technology is being currently tested in King County in Seattle. So originally the idea was to test it on an actual CSO facility, but due to logistical reasons, it was decided to test it at a wastewater treatment plant. And this is a 300,000 gallons a day unit, and it is currently receiving primary clarified effluent, which is kind of the SSO standards, not really CSO, but closer to SSO standards. There were two, the whole testing is in two parts. There's a preliminary testing and then there's a more formal. We are currently at the end of the preliminary testing. So some of this data we are sharing is part of the preliminary data we gathered at King County. So turbidity is a good indication of the amount of pathogens in the effluent. And we found that we were able to get really good results, very low turbidity, less than 0.2, which is a reuse quality effluent. And we got that within 2 minutes. So which is very critical data for a wet weather system to be able to meet the quality within 2 minutes. We also have seen data where storms lasted about 48 hours. The system ran consistently and sustainably at 100 GFD, which was the flux it was designed for, which is also 300,000 gallons a day, all through the storm event. 48 hours is an unusual storm period, but it ran through it for that many hours, despite of the blue line shows the TSS, how it varied up and down, but it was consistently performing at that level. Recovery is extremely important for this application because it really depends on how soon a treatment system in wet weather system can and bounce back between a storm. So how quickly can a system treat to an effective level and then bounce back and be ready for the next storm? So what this shows is different test runs that we had. Most of them are a week apart, and some of them are longer. The blue line shows that the TMP level after a test run. So obviously the TMP goes up after a test run, and then we clean the membranes. The orange line shows how well the membranes were cleaned. These are way below the baseline TMP in many areas. So this shows how well the membranes were clean and ready for the next test run. And in between, there were dry periods. So this data really is crucial for us to understand how quickly this can recover and run after a dry period as well. So now we are working on a pilot technology demonstration unit at Alley Creek, CSO, New York. To give you a little background, Alley Creek is a very pristine creek with a lot of water recreational activities. There is a beach 1 mile downstream of the principal outfall. And once the enterococci level goes about 35, that triggers the chlosing of the beach. So New York is under a consent decree for meeting the TRC, the total residual chlorine level, and the SPDS limit for enterococci and fecal. So for that reason, they're currently testing this technology. It'll start in August probably. The unit is at the site and needs to be hooked up. CDM, Tetra Tech, and Parametrics are the engineers working on it. And the demonstration goals are, we would like to get the fecal less than 200, enterococci less than 30, demonstrate rapid treatment and sustainable operation at design flows for 24 hours. And then obviously the recovery, how easily we recover and clean up after the storm and how easily we are ready for the next storm. So key points from this technology: high quality effluent, small footprint, easy retrofit in existing tanks, no large storage required, automated operations. And then Eddie talked about Water Expert. That is a great feature to operate remotely. And these units could be centralized or decentralized at CSO or SSO facilities. With that, we would like to leave with this wet weather section with a vision of a world where we would be able to continue the water activities without interruption, even after a storm event.
Thank you, Ashwini. You have a couple of questions, so I think I'll ask one right now. I've seen TSS levels as high as hundreds and up to 1,000 in CSO with the first flush. How is your system planning to handle these kind of loadings?
So when we ran a test here in Austin, some of the numbers that we saw on TSS were that high. We did simulate those conditions, and we still saw consistently the same results of TSS removal. Of basically the TSS, it's solids, and anything about 0.1 is going to stay. 0.1 micron is going to stay in the tank and rejected by the membrane. So this can potentially be met, and it depends how long this 100 milligrams per liter hits the membrane. At some point, it will foul the membrane, and it will have to, there'll be cleaning needed to process that further.
Basically, it's a treatment like a membrane, so you just would expect it to still treat it. You just probably have to clean more often.
Yes, that's right.
Yeah.
And just to add something onto that, Elena, Ashwini, I mean, SiC has got a very wide range of TSS operating capability, particularly when you're in a non-biological treatment process, like what weather treatment is, where you're just dealing with solids. So what essentially would happen is when you get those high TSS levels, it's during the first flush, the system will basically be able to absorb that solid spike. And then obviously as the solids level comes down throughout the progression of the storm and drops, to fairly low levels compared to raw sewage, the membrane will essentially recover itself, even if it did experience any type of uptick in fouling due to the first flush event. So it really has to do with the ability to handle a wide range of solids without compromising your flux rates.
Okay, thanks, Mike. Okay, with that, we'll save some more questions for later, but I would like to turn it over to Christine Dugan, and she's going to talk about tertiary membrane, another exciting area that is new for us, and we're seeing some great results there. Go ahead, Christine.
Thank you, Elena. Yeah, we think with the benefits that SiC brings that you've heard about, that it really is a game changer for tertiary membrane treatment. So there's many technologies that are available for tertiary treatment, but to do highly advanced treatment like ultra low phosphorus or water reuse applications like IPR or DPR, traditionally membranes have been needed. So some of the applications that the benefits that come from SiC, like the higher flux, the chemical resistance, and the recoverability of the SiC membranes, some applications that are unique for us are where we need ultra low phosphorus, so phosphorus levels less than 0.1. Reuse, where you're going to need extremely clean water. We also, for plant water reuse, our membranes are very modular, and we can drop those into a chlorine contact chamber because they're very resistant to chemicals. And then we can use our SiC membranes to treat that water that's in the chlorine contact chamber and use that for plant water. So you don't have the additional costs that would come with providing an additional basin. And then you also are getting very clean water for your reuse. And then also any kind of difficult environments that would include algae, specifically lagoons. We have an order that's coming up for lagoons where we're going to be installing this. So we're very good at treating with algae. And again, the chemical resistance, we can hit that algae with chemicals and reduce fouling. Anything where you're going to have high chemical levels, low SRT, and then heavy metals. And then also any place where you need a double barrier option. So we're going to be able to do both the bacteria removal and where you need disinfection. So we have been, for the past 2 years, testing out our technology. We have a pilot here in New Braunfels, Texas. It's in a conventional plant, and we are taking the effluent from the secondary clarifier and treating it. So the plant has, we're at the plant, we're going to be doing Title 22 testing along with Black and Beach. We also are testing with ozone to see the flux enhancements from that. And then we also, through the pilot, have shown that we can achieve effluent phosphorus levels as low as 0.02, which is extremely low. So the plant uses residual dewatering polymer, and that creates a lot of fouling for any kind of membrane. In spite of the polymer, we at the pilot have been able to achieve 100 GFD for 3 weeks. And we also have done testing with ozone to see what kind of benefits that could come. And with the ozone testing, have seen that we can achieve 150 GFD for a very long time. So the pilot has shown that we've got that ultra high flux capability, that we can achieve very low phosphorus levels, and that we can use caustic and ozone for plants that would have EPS, algae fouling, or membrane scaling. So if you look at the slide here, it shows typical values of what we can achieve with BOD, TSS, phosphorus, etc. But on the far right side, this is what we've actually been able to achieve with our pilot. So non-detect levels of BOD and TSS, again, that phosphorus level of 0.02, turbidity levels of 0.05, non-detect of fecal coliform, and then less than 2 for SDI. So very, very clean water in a very maintenance-free operation. And then if you look at the different options that are available for tertiary treatment, we have our UltraBlocks package plant that's shown on the right. This can treat up to 1 MGD flow. It's completely plug and play. It can go indoor or outdoors, and it includes everything from screens to disinfection. So it's very easy to use. We also can go to in concrete design, and that's going to be for larger installations, but it's still very compact and modular and easy to use. And we can basically retrofit any kind of tank because it is so modular. So these can drop into any kind of tank and handle any kind of conditions. Our modules, we can go up really high or we can go very low. So we can even do shallow tanks. So we're really excited about it. Are there any questions?
Actually, you have a couple of them. So let me read that real quick. Okay, is it easy to retrofit existing side stream polymeric membrane systems with SiC?
Yeah, it is easy to retrofit. It's easy to we have really high flux and we can fit in shallow tanks. So we can really retrofit any kind of process. Also with side stream processes, I know that a lot of times the BOD and TSS is very high, and we're very capable of handling those and reducing those.
Okay, you have another one. Do you have advantages on life cycle cost with this technology?
Yes, we do. So if you look where we're removing phosphorus, through our tertiary pilot, we've actually seen that our molar ratio is 1/6 that of competing technologies. So, and that's especially true at those very low phosphorus levels. So where other technologies are going to require you to hit the process with a lot of chemical to be able to remove the phosphorus, we're able to do so with very low chemicals. And so that's going to mean less chemical costs, and it's also going to mean less sludge that's generated.
Okay, we have another one, but it's for Ashwini, so I think I'll wait for it at the end. But okay. Thank you, Christine. So our next and final speaker is Martin. So if you guys have any more questions coming in, just send them in, and right after Martin, we would have extra time to ask all the other questions to everybody. Martin will finish off with the MBR, the revolutionary membrane for MBR. Go ahead, Martin.
Revolution MBR systems, right? So I've been with the group since 2004, very early on, and I know we've got a long history up in the Pacific Northwest with our MBR installations. I think over 50 or so that we've done up that way. Most of you guys on the phone or on the call know MBR pretty well. So what I really wanted to do is take the time now to really kind of give an update of kind of where the MBR group is kind of today and kind of where we're going. So Mike, go ahead and go to the next slide there. So to date, there are 65 SiC installations worldwide, and these installations are a variety of applications from MBR to thickening to water applications and so forth. Ovivo, us personally, have done 28 installations already. Our first installation was in 2017. I think Mike mentioned that the ultra pure water folks from Ovivo were actually in 2015 was their first installation. So we've already got quite a good installation base going. These are just some of the MBR applications, and we've got plants running from 440,000 gallons a day down to our microblocks plants is 20,000 gallons a day. We've got a wide variety of the applications for the MBR market that we've already done, and a lot of them are operational. Belfray, Kentucky is our, call it our first traditional in-ground MBR system utilizing SiC. This is actually a sister plant to another facility in Kentucky run by the same operations owner. And the first plant we did with the polymeric, but once we introduced the SiC to them and kind of demonstrated everything that Mike and Eddie and the folks have been talking about, they felt that it was a better operational value for them because they're an operations group as well. And they decided to go with SiC on this second plant. This unit should be, this plant will be up and going probably, I think it's next month is when it will be started up. The village of Taos Ski Valley, New Mexico. This is a microblocks / retrofit. There was an existing activated sludge plant. Interesting thing about this particular plant is we won it originally with our polymeric membranes, and everything was going to be kind of in basin. They were going to add some extra concrete basins, and it was kind of be more of a kind of a, I call it a retrofit, traditional sort of application. It went out to bid. It bid in at like $11 million, and they only had $8 million in the budget. So we took a look at doing a package plant offering for the membranes and some of the tankage. And because the SiC has the high flux and the better packing density, we were able to pack a lot of hydraulic capacity into our package plant. So this is our XL unit that you can see in the picture there that's kind of going in. The job bid out, and obviously we kind of won it. It went under budget. I think we saved $4 million compared to the in-ground version. So very challenging application as well. It's 9,000 feet elevation. Temperatures down to 7 degrees. We've got very tight TN limit. I think it's less than 5. Phosphorus as well. The flow rate varies from 60,000 gallons a day in the summertime to winter when everybody's up there skiing, 440,000 gallons a day. So the capability to have the turn down and even isolate and drain basins during the summer was also very attractive as well, because again, as the other folks explained, these units can be dried out. They don't have to be preserved or anything like that. So the basins can be drained, cleaned up, and just set idle till they're ready to be needed for the next season. So that was a big advantage for them. This is another one of our smaller microblock systems, and this is for a school district, and kind of the same thing as the Ski Valley, variable flows, next to nothing in the summer when school is out. So the constructed cost and the ability to be able to shut down the plant and not have to worry about it, not necessarily have to keep the biology happy and all that sort of thing. You basically just shut it down in the summer, drain it down, and then when you're ready to kind of get back up going in the when the school time comes, seed it, and you're ready to kind of rock and roll again. And then this last one is at a older facility that was in Ohio that we supplied some of the Kubota membranes to. They have, we're in the process of upgrading the polymeric plates to the SiC. And with this being a more of an industrial application, you know, these membranes take a bit more of a hit. So the longevity of the SiC as compared to the polymerics and the wider operational window that they really need to keep the uptime at this particular plant was really important to them. And we increased the flow a little bit within the existing basins as well. So it was a kind of a win all the way around. Now, the nice thing about the SiC membranes that we did not have with the polymeric is that we now have the ability to be able to fit within the hollow fiber basins. So we can convert the hollow fibers as basically any of them, which we were not able to do in the past. And then I just wanted to leave you with this slide here. The industry is always chasing that ultimate achievement in technology. And I think we've kind of demonstrated today that that ultimate achievement for our, you know, our market, the membrane market, whether it's tertiary or MBR, is that ultimate achievement. So I'll leave again with, what if you had a membrane? And
thank you, Martin.
You're welcome.
Our closing slide is just a summary slide of some of the advantages that hopefully you would feel about the limitless possibilities of SiC. I think this captures, you know, the fact that the reason we're so excited about this is the fact that you can do so many unique things, because it is 100% recoverable because of our hydrophilicity, porosity, and strength of the product. So those three things, and I hope that, you know, Mike was able to set the stage, and then when Eddie presented technologically how that has changed his life and the life of our customers, we really think that we can expand more than that 2-3% of wastewater plants that are the only ones that really have membranes. And we hope with wet weather as a new opportunity, as well as tertiary, that will be another way to do it. I do have a few more questions for the team. So if you guys can all turn your cameras on and go off mute. A couple of questions that came in. Martin, just appropriately for you, since you just finished, if you had a hollow fiber polymeric, that's what this guy has, can you convert that, he said, to SiC? So right. He has you talked about some of the installations we have, but the question is, can you do that?
Yes, absolutely. I think I mentioned at the end there, our footprint now is almost identical, if not better than what the hollow fiber footprint is. So being able to fit into the existing basins and maybe even get a little extra hydraulic capacity out of those basins is absolutely a possibility. a lot of the hollow fiber already have the infrastructure in place for backwashing and that sort of thing. So that fits well with the SiC, and obviously the the operational window and the cleaning ability and all those nice properties of the SiC are more favorable than the hollow fiber, including the longevity of the life of the membrane.
So it may be appropriate to ask Mike the question because that came in earlier, but you already switched to Ashwini. How is the membrane made? And I'm not sure if it's talking about the structure of it or how is it made, manufactured. Go ahead, Mike, explain in your own words. I don't know how to explain the question, but that's all it says. Yeah. What is the membrane made out of? So I mean, they know it's silicon carbide, but right. Maybe the consistency, how the product is made. Go ahead.
So the membrane is made through a couple steps, and the first step is to produce what we call the substrate. The substrate essentially is the support for the membrane. It also provides the passageways for the permeate water, and probably comprises 99.99% of the overall material. But that substrate is first made by you create a paste of SiC, very much like Play-Doh, both in terms of its consistency and thickness. You extrude that into a plate form, and then that plate is fired at 2,000 degrees Celsius. Obviously, not many materials can handle that high of a temperature, but what the firing does is it bonds the individual grains of SiC together. After the substrate is made, then it's coated with another layer of SiC particles, much smaller particles that essentially create the pore size and the pore structure. And once that's coated with SiC, then once again, it is fired at 2,000 degrees Celsius. So you end up with a material that is just 100% silicon carbide. Obviously, there's different size particles, but it's also a monolithic material, meaning that all of the SiC grains are bonded to one another. So it's a very unique product and material because it's no longer is it a layer that's cast on top of another layer or a film that's adhered to another film. In this case, all the individual particles are bonded to one another.
Thank you. This question, he says, can you remove ammonia? But the question that came in, I'm not clear if it's on an MBR, which obviously we already know the answer to that, or if it's tertiary wise. Can somebody take the question? And maybe Ashwini is more for you, but I'm not really sure who the question is addressed. Like what area? Is it MBR? Is it wet weather? Is it tertiary? Maybe you want to take it, Ashwini.
Yeah. Either case, removal of ammonia is going to need some kind of biological treatment. Tertiary and wet weather systems are not biological systems. So if the system, the person who's asking the question, if they're referring to MBRs, then yes, they can reduce ammonia.
Right.
A wet weather system and tertiary intrinsically, they are not designed as biological treatment systems. So they won't be able to reduce ammonia.
Okay, if that is not satisfactory answer, please send me another question and then I will clarify it again. This one is definitely for you, Ashwini. What would the disinfection requirements be downstream of the wet weather system?
That's a good question. The typical CSO limits that we see are fecal of less than 200 and TSS reduction of 50%. So technically the membranes are capable of getting to this level, less than 200 fecal, less than TSS of removal of 50% for sure. Membranes are capable of getting to that level. It really depends on how the regulators look at it and if they need a secondary barrier to able to decide whether this needs disinfection or not. In either case, I think the disinfection needs are going to be lower than any other technology, just because the effluent quality is so high to start with. And with if that question is related to SSOs, typical SSO permit limits are also less than 100, BOD less than 45, TSS less than 45, and turbidity less than 0.5. So these are very achievable for membranes.
So the other question for you was, and I think I'm explaining it, it's kind of wordy, but can you actually put it in New York City? They were looking at the New York City when you were presenting about New York City. Can that really be underground? So I'm assuming that's for downtown New York City or Seattle in this case, or Portland, or can it be right next to a wastewater plant and be underground? I guess you can answer it both ways. Because I think the question, it's anonymous, so I can't really ask the person, but
sure,
it is downtown, right? That's what you're doing in New York, correct?
Yes, it's in Queens and Queens, New York, and it is very much possible to have this system below grade. And that's how we are showing it in a couple images. The membranes can fit into existing retention tanks. If they are existing, we could just drop membranes in there, and because of the high flux, they should be able to handle a lot of flow in a small footprint, leaving the rest of the area for the other equipment that's needed, blowers, pumps, and chemicals for membrane cleaning, all of that.
Okay. So the question came back again, the individual is saying, yeah, it was about tertiary. The ammonia question was about tertiary treatment.
Okay.
So another question that came in is, can your module be stuck up to increase capacity if the tank is deep enough? Maybe Mike, you want to take that, because it could be for any one of the applications, I assume, since the question is not clear if it's MBR or if it's wet weather, but you probably can answer that from a technology point of view overall.
So the question was, can you go high in terms of the stack to increase packet density?
Yeah.
Yeah, absolutely. I mean, obviously there's eventually a weight limit in terms of what the module structural components can withstand. But yes, it's one of the nice aspects of the technologies that is very modular. So you can go higher to take advantage of deeper basins and decrease your footprint.
Okay.
Hey, can I add something?
Yeah, please.
Basically, there are individual modules. The modules are about a half a foot, so they're all stacked on top of each other. You can either have one module, or you can go up to basically as high as 15 high modules. So we can fit in very shallow basins as well as take advantage of deeper tanks as well.
Okay. This question, either Mike, I can answer it, Mike. The question is, when is your factory in Texas going to be open, and can I visit? So April 2022 is our time that we're opening up the factory. Hopefully with coronavirus, that would still happen. Our Center of Excellence is also here in Austin, and it's actually the global Center of Excellence for the technology. We already have R&D being done even in our building. We have a brand new building that we bought, I guess, 8 months ago now, and we're doing R&D there. We also have a lot of pilots that they're within the area, not too far from Austin. So yes, if you want to visit when everything is clear, like you can see, every one of us is working from home still, because Austin is really one of the difficult cases right now. But eventually, we would love to have you come over to the factory, also visit some of our pilots. And again, we hope that this webinar would generate enough interest to talk to Victor as a follow-up and set up meetings for the individual product managers. But definitely everybody is welcome to Austin. Yeah, that's not even a question. Okay, any final comments from our guys? It's 12:40, so we're early, and we're about 20 minutes early. So any final comments, Mike, that you may want to make before we close this?
Yeah, other than just to, sort of summarize everything, I mean, this really is an exciting new technology. This membrane has done things I've never seen any membrane technology do, and I'm very fortunate to be along for the ride. So we're really excited about its possibilities.
Absolutely, absolutely. So with that, Victor, thank you so much for putting this together. We apologize that it is on Zoom, but right now this is just the way it is. Hopefully, if we cannot travel, we would love to do an in-person and like our typical like one-day thing, that we do.
Yeah, it'd be nice to get you guys out here after this Corona thing is over and visit some clients and make some calls. But
yeah, and it's hard to do a Zoom that lasts more than 2 hours. But when we do the actual workshops that we used to do before, I mean, it can go half a day and we can go more in depth. Otherwise, it's just very, very difficult. But if you guys have any other comments, please contact Victor or me, and looking forward to more information shared from them. If they have more questions, just send them in. And I appreciate everybody's time. Thank you, guys.